Hi everyone, this is Pasadena City College, and this is where we are going to start our tour to show you some hazards around the globe. So for each city and hazard we'll see, I'll tell you what is happening, why it's happening, and what we can do about it. Our first stop today will be Denver, Colorado. We will be going there to look at tornadoes, which is atmospheric hazards. And the reason why we chose Denver is because we thought it was interesting. If you were to look at a map of tornadoes, you would see that they are mostly happening on the eastern side of the city, and the closer you get from the western side, the less tornado there are and the weakest they are. The explanation for this is that if you look on the left side here, you can see it becomes green, and this is actually the Rocky Mountains. So they will act as a natural obstacle, and the tornadoes just won't go further because they won't have enough energy to feed off. Then the reason why there are tornadoes in the first place is that this part is actually part of the Midwest in the United States, and we would call it also Tornado Alley, where the warm air from the Gulf of Mexico comes up and meets with the cold air from north, and it creates an unstable air that results in thunderstorm. From those thunderstorms results tornadoes. So this is why there are so many tornadoes in this area. One of the solutions would be to make everyone aware of what to do in case of a tornado, because turns out not everyone knows, and this results in a lot of life lost. So our second stop today will be in Mungo, Chad. We are here to look at the drought, which is part of the hydrospheric hazards. So if you look at the region, you can see that most of it is dried up. The reason for that is the topography of the terrain and also the hot climate that just won't allow water to come in this area, and it results in up to 10 months of just drought in 1 year. So one of the solutions we thought about is to bring them fuel run generators, which would allow them to extract more water from the ground, because in this area, especially in Africa, they don't have access to clean water or to just water at all, because they don't have funding, they don't have money. It's overpopulated places with underfunded everything. So if we bring them generators, they can take more water, and if we bring them staff, like technical staff and administrative staff, to just organize everything, it would be really helpful for them. Finally, our last stop will be in Peru, South America. We are going there to look at earthquakes, which is a lithospheric hazard. So if you look here, you can see a line. This is actually corresponding to the delimitation between the Nazca plate on the left and the South American plate on the right. So what happens is the Nazca plate is an oceanical crust, and the South American plate is a continental crust. So when they collide, when they meet each other, the oceanic plate, Nazca plate, will just dive under the South American plate. This shock will create earthquakes. And so, because the shocks are originating from this area, if you look at a map of earthquake, most of them will be around here. And the further you go inside the continent, the less earthquake you have, because, well, it's in the middle of the plate. One of the solutions for that would be to build anti-seismic buildings that just won't collapse in case of an earthquake. It would result in a lot of lives saved. So here it is for today, guys. We are going back to Pasadena City College. I hope you enjoyed it. Bye!